Hello everybody. Today we want to talk about best practice in GUI development, and the topic is live data prototyping. What's important here? In many projects, from concept to final delivery, the user interfaces and the underlying middleware are developed by separated teams. This approach requires a good interface and a detailed description of the data to be exchanged. Errors in this interface are often only discovered during integration on the target, and even if the hardware is available in a very late phase. What's quite important here, bringing the GUI and the middleware together in an early stage can save a lot of time and money here. But how this can be realized when the target hardware is often not available yet? We would like to show you a technique that our GUI Services team has been using in many customer projects since over 20 years. Also here you see one of the projects is a Löbe project where we did this for more than 10 years developing TV UIs for different TV set brands. Okay, what's important here? GUI development with a prototyper. I want to talk about the challenge, the solution, and the advantage you will have with this. So the lessons learned from our projects in globally distributed teams. The challenge is you have separated teams all over the world, or maybe also locally. You have to define a comprehensive interface definition, and that's very important that everybody exactly knows which data to deliver and which data to expect. And in addition, you have to define test data for the timing behavior, for the data models, and for all your value ranges which you want to exchange. Now, what you can do here, the solution, it's Embedded Wizard's prototyper. With this, you also can really use real data from your middleware. And this helps you co-working of the teams. So the design team, as well as the development team, and also testing and marketing team can already use this data during the design and evaluation and development phase, and that helps because it can easily be exchanged without exchanging any hardware. And now the advantages which you have with this solution, it's globally available at an early stage. You will have no surprise in the data flow. There is a low technical hurdle to implement this. You get some realistic behavior with dynamic data. There is less creation of extra test data because you already get your live data which you can use for testing. So this brings you significant time savings. You get an optimized workflow, and this not just for the development, for the whole teams involved for the product. Now I will not talk about the Löbe UI because I did not bring a TV set with me. Today I brought with me a small set with a prototype and MQTT. And what I will show you here, I have a target system with Raspberry Pi running the broker and running the client, and the prototyper with Embedded Wizard, where I show everything. So you see here on the slides, on the target system, later on there will be running the application using some widgets, and these are connected with an MQTT data binding. On the target system, then this is using the Coda compiler generated to NCC code. It's then using the interfaces on the MQTT library, and it runs on the target device. For the prototyping itself, it's mainly the same. So here you have your application, also the different set of widgets and the binding, but the prototyper then is using the MQTT intrinsic module, which is connected to the MQTT library, and will bring all the data from the MQTT devices to the prototyping environment. Okay, now I want to switch to Embedded Wizard just to show you what's available here. What I brought with me, it's an already small project where I have an MQTT interface implemented, and here you see a lot of different classes which just connect to the MQTT topics and the different attributes. So for example here, let's say here I have a Shelly door window sensor. There is a topic where I connect to, and then I just get all attributes from this because it's a single value. I also have here some widgets And these widgets are just connected with these data parts. Let's see here on the door, I have some custom properties, and maybe also here some values are connected here to the MQTT door window contact, or to the looks, or to the battery values. When I start prototyping, I directly will get here some live data. So I start prototyper. You see already here on the prototyper it's connected, and it immediately will interact here with the broker and communicate with the devices. So when I press on the plug 2, immediately the light turns on. And I also see here the power consumption and can see what's the temperature, what's the current power consumption. When I turn off, immediately I also see how the widget will react. The same also for other lights. I can turn on, I also can dim here, and in the same way I can interact and also can see here how the different data values are coming in. But why live data prototyping is so important? Maybe here for the door sensor, the designers expected that all the values coming in are at a range from 0 to 100. But in real data you see that different values are coming in. So here I have my door window sensor. It's battery driven. It delivers all the data a few seconds delayed. I also will see this and I can react on it. But now I see that the luminance sensor inside, it delivers much higher values. And you see already here, the values are more than 1,000, so it can even get higher. And I do not see nothing here on the graph. But how to adjust this? I easily then can go to my widget and change the values. So I would say that the max value maybe goes through 9,000, the min value stays, and for the precision, I don't need high precision because it's a simple value. If I start prototyping again, then immediately you see that these values are now reflected, and now I turn also on the light. I also change a little bit here the luminance value, and as soon as this is reflected, you also will see it's changing here on the graph. And this allows you to adjust all your visualization of the data values in a very good way with live data. And now the next stage, it's not just here that you do all this on the prototyper. The same what you see here on the prototyper, you will immediately get also on the device as soon as you generate the code. That means now with this, I also generate the code for my Raspberry Pi. And as soon as code generation is done, I just connect it and let rebuild. So I simply stop the application which is already running here. And as soon as the generation is done, I also will build again the whole stuff. Let's just wait. Code generation, it generates on a network device for the Raspberry Pi. It's done now. I start the build process. It's compiling directly here on the Raspberry Pi, all the stuff which I just generated. And as soon as this is available, I also can check it here and just have a look. You also can see here that this look sensor now is adjusting in a value range from 0 to 9,000. And that's what I want to see. And it's reacting in the same way as I did on the prototyper. Okay, I hope that this helps you a little bit understanding how you can easily work with live data prototyping and using the Embedded Wizard prototyper for your whole development teams. Thank you for your attention.